Hello everyone, you all are welcome. So today in this video we are going to learn the definition of inverse matrix, the process of finding inverse and some problems related with inverse matrix. So let's take a start. You can see here the definition of inverse matrix is to every square matrix A there exists the another matrix B such that AB is equal to BA is equal to I. It means the product of AB and the product of BA is equal to I, where I is an identity matrix. Value of identity matrix is 1001 is called inverse of the matrix A. It is denoted by A inverse and read as A inverse. Now I will show you the process of finding how to find out inverse. So for A, suppose we have A is equal to A, B, C, D and determinant A is not equal to 0. It means non-singular matrix. Then to find out A inverse, what we have to do? A inverse is equal to, we have a formula 1 by determinant A, and we have to interchange the main diagonal. We already found the adjoint of a matrix before. In same process we have to do, we have to interchange the leading diagonal or main diagonal. In the place of A we have to write D, and in the place of D we have to write down A. So here we have to write D, here we have to write A, and non-diagonal remaining elements we have to change the sign. If positive we have to write negative, if negative we have to write positive. You can see here is B, so we have to write minus B. Here is C, so we have to write down minus C. Okay, so in this way we have to find out the value of A inverse. Or you can see here 1 by, to find out determinant A, what we have to do, we have to multiply the main diagonal A into D minus B into C. So we can write here AD minus BC and D minus B minus C A. So in this way we can find out A inverse. Now we are going to do some problems related with inverse function. Look at the question number 1. Okay, we have a question. If A is equal to 7432, find A inverse. We have to find out A inverse. Look at properly here. Here A is equal to 7432. We have to find out A inverse. First of all we have to check either this matrix A is singular and non-singular. So for that we have to find out determinant A. To find out determinant A we have to write inside vertical line. This two vertical lines shows that we are finding determinant of matrix A. Now to find out determinant, what we have to do, we have to multiply the main diagonal 7 into 2 minus we have to multiply the non-diagonal 3 into 4. 7 into 2 14 minus 4 into 3 12 is equal to 2, which is not equal to 0. It means therefore determinant A is not equal to 0, so A inverse exists. If we get here determinant 0, then we cannot find out the inverse of matrix A. Now to find out A inverse, what we have to do, I already gave you formula 2. So let's find out A inverse. To find out A inverse, what is the formula? 1 by determinant A, and what we have to write, we have to interchange the main diagonal. We have to interchange the main diagonal. In the place of 7 we have to write 2, and in the place of 2 we have to write down 7. So here 2 and here 7, and non-diagonal remaining elements we have to multiply by minus, or we have to change the sign. If positive we have to write negative, if negative we have to write positive. So we can write here minus 4 minus 3. Elements no need to change. And what is the value of determinant A? 2. So we can write here 1 by 2, 2 minus 4 minus 3, 7. You can multiply or you can leave up to here also. When you multiply, what we get here, 1 by 2 into 2, 1, 1 by 2 into minus 4, minus 2, 1 by 2 into minus 3, minus 3 by 2, 1 by 2 into 7, 7 by 2. This is the answer of A inverse. Hope you understand this question number 1. Now look at the question number 2. Prove that the matrices, two matrices are given here, 2 minus 5 minus 1 3 and 3 5 1 2 are inverse of each other. We have to show that these two are inverse each other. It means the product of these two is equal to identity matrix, then they are inverse each other. Let's start. Let A is equal to this matrix, 2 minus 5 minus 1 3, and B is equal to 3 5 1 2. So let's write on to show that A and B are inverse of each other. To show that inverse of each other, what we have to show, or we have to show AB is equal to BA is equal to I, where I is an identity matrix, where I is an identity matrix of order 2. Okay, so now we have to find out the product of AB. Matrix A is equal to, what is here, we let here 2 minus 5 minus 1 3, and the matrix B we let here 3 5 1 2. Let's find out the product of AB, and then we have to find out the product of BA, and we have to check either they are equal with identity matrix or not. Identity matrix means 1 0 0 1. Let's multiply this one. I'm going to multiply directly. Rows into column, 2 into 3 6 minus 5 into 1 minus 5. Now row into second column, 2 into 5 10 minus 5 into 2 minus 10. Again second row first column, minus 1 into 3 minus 3 plus 3 into 1 3. Again second row second column, minus 1 into 5 minus 5 3 into 2 plus 6. Now when you solve this, what we get here, 6 minus 5 1, 10 minus 10 0 0 1. Now look at here, this is identity matrix, but we have to check BA, they are inverse each other or not. To show that, we have to find out AB also, we have to find out BA also. Now matrix B is equal to what, this one, 3 5 1 2, and matrix A will let 2 minus 5 minus 1 3. Let's multiply this two and check either they are inverse each other or not. Okay, first row first column, 3 into 2 6 plus 5 into minus 1 minus 5 we can write. Okay, first row second column, 3 into minus 5 minus 15 plus 5 into 3 15. Second row first column, 1 into 2 2, 2 into minus 1 minus 2. Now second row second column, 1 into minus 5 minus 5 plus 2 into 3 6. Now when you find out the answer, what we'll get here, when you solve this, 6 minus 5 we get 1, here we get 0, 2 minus 2 0, and here when you solve 6 minus 5 1. Now you can see here again we get here 1 0 0 1. So what we can write here, therefore AB is equal to BA is equal to I, and at last we have to write down, so A and B are inverse of each other. Hope you understand this question number 2. Now look at next question number 3. You can see here we have a question, if m4 minus 1 3 and 3 minus 4 1 m, these two matrices are given, are inverse each other. These two are inverse each other. Find the value of m. M is here. Okay, when these two matrices are inverse each other, it means the product of these two matrices is equal to identity matrix. Let's take a start. Given m4 minus 1 3 and another matrix 3 minus 4 1 m are inverse each other. inverse each other. So the product of these two matrices is equal to, so we can write here m4 minus 1 3 and 3 minus 4 1 m is equal to 1 0 0 1. The product of these two matrices is equal to identity matrix 1 0 0 1. If any matrix are inverse each other, so when you multiply that two matrix, always we get identity matrix if inverse each other. Now let's multiply this and find out the value of m. First row, first column, m into 3 3m plus 4 into 1 4. Again first row, second column, m into minus 4 minus 4m, 4 into m 4m. Similarly second row, first column, minus 1 into 3 minus 3 plus 3 into 1 3. Second row, second column, minus 1 into minus 4 4 plus 3 into m 3m is equal to 1 0 0 1. Okay, up to here. After this we cannot add, they are unlike terms, so we can write 3m plus 4, and here both cancel, one positive one other negative, so 0. Here also 0 we get, and here 3m plus 4 we can write is equal to 1 0 0 1. Hope you understand up to here. After that we have to equating both sides, equating corresponding terms, so we get 3m plus 4 is equal to 1, and after that we have to solve and we have to find out the value of m. 3m is equal to 1 minus 4, 3m is equal to minus 3, so m is equal to minus 3 by 3, therefore the value of m is equal to minus 1 is the answer. Another one also, 3m plus 4 is equal to 1, and same thing, so when you will do, you will get here minus 1 only answer. Here we have a question. You can see here, if the inverse of the matrix this is the matrix, this means inverse of this matrix is this, calculate the value of m and n. M is here, n is here, we have to find out the value of m and n. So here what is given? Here inverse of 2m 7 5 9 is this matrix 9 and minus 5 4. Inverse of matrix this is this. Okay, so when you multiply these two, we get identity matrix, they are inverse each other. So what we can write here, 2m 7 5 9 into this matrix 9 and minus 5 4 is equal to identity matrix 1 0 0 1. Inverse of this matrix is this, so when you multiply this two, we get always identity matrix. Now multiply this two, first row into first column, 2m into 9 9 to the 18, so 18m we have to write, plus minus minus 7 into 5 35. Again first row into second column, 2m into n 2mn plus 7 4 the 28. Now second row first column, 5 into 9 5 9 the 45 plus minus minus 9 5 the 45. Again second row second column, 5 into n 5n plus 9 4 the 36 is equal to 1 0 0 1. After that comparing, equating both sides, equating the corresponding items or value, or equating both sides, as you wish. You can write anything here. So what we can, this is equal to what, 1. We can write 18m minus 35 is equal to 1. 18m is equal to 1 plus 35. 18m is equal to 36. M is equal to 36 by 18, therefore m is equal to 2 we get here. Similarly If you take this is equal to 0, we have to put the value of m, then we can get value of n, and 45 minus 45 is equal to 0. If you take this, I think it's better. 5n plus 36 is equal to 1. No need to put, when you take this 2m plus n plus 28 is equal to 0, we have to put the value of m from here, and then we can calculate, or directly you can take 5n plus 36 is equal to 1 and solve it. 5n is equal to 1 minus 36. 5n is equal to, when you subtract, we get 35. Now this in multiplication, so we have to divide. Minus 35 by 5, so n is equal to minus 7. So therefore the value of m is equal to 2 and the value of n is equal to minus 7. Hope you understand this question number 4. Now look at next question number 5. This question is totally different than before. You can see here, if a is equal to 2031 and b is equal to 0124, then prove that, we have to prove here ab inverse is equal to b inverse a inverse. We have to show that, we have to prove that ab inverse means inverse of ab is equal to b inverse a inverse. So we have to find out the inverse. Here ab is here, so we have to find out the product of ab first of all. Okay, let's take a start. Solution: a is equal to, here given 2031 and b is equal to, we have the matrix 0124. Okay, first of all we have to find out determinant a. We have to check, can we find out a inverse or not. If determinant 0, we cannot find out a inverse. So 2031 is equal to 2 into 1 2 minus 3 into 0 0 is equal to 2, which is not equal to 0. So a inverse exists. A inverse exists. So we can find out a inverse here. So how to find out a inverse? 1 by determinant a we have to write, and after that we have to interchange the main diagonal. In the place of 2 we have to write 1, in the place of 1 we have to write on 2. So 1 2, and non-diagonal we have to multiply by minus, or we have to change the sign. So here is 3, so we have to write minus 3. Here is 0, so minus 0 and 0 same thing, so we can write here 0. Now what is the value of determinant a? We have 2, so 1 by 2, 1 0 minus 3 2. Leave it up to here, no need to multiply by 1 by 2. Now for b we have to do, so first of all we have to find out b inverse, and then determinant b, then we have to find out b inverse. Determinant b is equal to, b we have 0 1 2 and 4, so we can write here 0 1 2 and 4. In same thing we have to cross multiply. First of all we have to multiply the main diagonal. 0 into 4 0 minus from formula, and non-diagonal 2 into 1 2 is equal to minus 2, which is not equal to 0. So b inverse exists, we have to write down, and after that we have to find out b inverse. To find out b inverse, formula is 1 by determinant b, and here we have to change the main diagonal. In the place of 0 we have to write 4, and in the place of 4 we have to write down 0, and non-diagonal we have to multiply by minus, or we have to change the sign. Here 4 0, and this side multiply by minus 2, and here minus 1. Suppose here is minus 1, then we can say minus 1. Here we have to write on b. After this, what is the determinant b? We have minus 2, so we can write here 1 by minus 2, and 4 minus 1 minus 2 0. Hope you understand up to here. We have a inverse, b inverse. Okay, now b inverse we found, a inverse also we have to found, and we have to find out the product of b inverse a inverse. Now let's find out the product of b inverse a inverse. B inverse a inverse, b inverse is equal to, what is here, minus 1 by 2, 4 minus 1 minus 2 0, and a inverse is equal to, what is here, 1 by 2, 1 0 minus 3 2. Now let's multiply this one. Minus 1 by 2 into 1 by 2, 1 by 4, and this 2 matrix we have to multiply. 1 0 minus 3 2. Let's multiply this 2 matrix. minus 1 by 4. First row into first column, 4 into 1 4, minus 1 into minus 3 plus 3, we get minus minus plus. Okay, first row into second column, 4 into 0 0, minus 1 into 2 minus 2. Now second row first column, minus 2 into 1 minus 2 plus 0 into minus 3 0. Second row second column, minus 2 into 0 0 plus 2 into 0 into 2 0. So what we get here, minus 1 by 4 is 7, minus 2 minus 2 0 we got here. This is the value of B inverse A inverse. So minus 1 by 4, 7, minus 2 and 0. So when you take from here minus common, or if you leave up to here also, or when you take minus common also here, what happened when you take minus, or when you multiply this minus here, so what happened, 1 by 4 when you multiply by minus, then this minus into minus 7 minus plus minus plus and minus into 0 0. So we get this much. This is the value of B inverse A inverse. Now we have to find out the value of AB. First of all, we have to find out the product of AB, then we have to find out inverse. Let's multiply AB, find out the product of AB. A is equal to, we have 2 0 3 1 and B we have 0 1 2 4. Let's find out the product of this two. First row into first column, 2 into 0 0 0 into 2 0. First row second column, 2 into 1 2 0 into 4 0. Second row first column, 3 into 0 0 plus 1 into 2 2. Second row second column, 3 into 1 3 plus 1 into 4 4. So what we get here, 0 2 2 7, we get this much. After this we have to find out AB inverse. To find out AB inverse, we have to find out determinant AB. To find out determinant AB, what we have to write, 2 0 2 2 7, we have to write inside vertical line. 0 into 7 0 minus 2 into 2 4 is equal to minus 4, we can write. Now we have to find out AB inverse, and the formula is 1 by determinant AB, and we have to interchange this two, and non-diagonal we have to multiply by minus. In the place of 0 we have to write 7, in the place of 7 we have to write on 0. So 7 here 0, and non-diagonal we have to multiply by minus 2 minus 2. Okay, now 1 by determinant A is equal to, what we got here, minus 4. 7 minus 2 0. Now this minus multiply these all number, so what we get here, 1 by 4 minus into 7 minus into minus 2, we get here 2 minus plus, so we get here 2, and minus into 0 means 0. Now we get AB inverse is equal to 1 by 4 minus 7 2 2 0. Now you can see here what is the value of B inverse A inverse. Same thing, 1 by 4 minus 7 2 2 0, and here also same. So at last we have to write down AB whole inverse is equal to B inverse A inverse, proved. Hope you understand this questions, and if you like this video, if you understand, please hit the like button, and if you are new on my channel, please subscribe and share with your friends. Sharing is caring, so do not forget to share. And you can join my Facebook page, which is on description. Thanks for watching till last.